Fine. So the nth term of a quadratic looks like this: a n square plus b n plus c. That is the nth term of a quadratic sequence. Okay. Now what I'll do, turn by turn, I will put the values of n as 1, 2, and 3, and I'll show you the whole pattern. Okay. If I put the value of n as 1, my first term will be a plus b plus c. Is that okay?
Yeah.
Okay. Then, if I put n is equal to 2, then the term will be 4a plus 2b plus c. Okay.
Yeah.
If I put n as 3, then it will be 9a plus 3b plus c. And so on, it will go like that. You keep on putting n values, you will get different terms. Now, the
Yeah.
reason for doing all these things is we need to find a way to get A, B, C values, because the questions will be to find the nth term. Mostly the questions are like that only. Okay.
Yeah.
So in order to get the nth term, you need to have A, B, C values. These will be some whole number constants. Okay.
Mhm.
Usually there are some whole number constants, but they can be negative as well. Okay.
Yeah.
So what I'll do, I'll take the first difference from the terms. Like this is the first term, second term, and the third term. Okay. I'll take the first difference. Like I'll take the difference of two terms and I'll write it down over here. After taking the difference, what am I getting? 3a plus b.
B.
Okay. If I go ahead, the other one, this difference, okay, how much it will be?
5a plus b.
A plus b. Okay. Then I will go further. I'll take the difference of these two terms again, and that difference will be 2a.
2a. Yeah.
Okay. So now from here, we have some conclusions like 2a. In the end, we will be left with such a term which when divided by 2 will give me a, because my target was to get a, b, c values.
Yeah.
Okay. 3a plus b will be a term from that sequence that will give me one equation, and then a plus b plus c will give me another equation. Now this is a very theoretical, that's why it is not giving us that feel. But when we will do it for one question, then it will definitely be more clear that what we have to do in this. Okay. So from these differences, we have to take care of these three expressions. And these three expressions will be equated with the numbers, the literal numbers of a proper quadratic sequence. Okay. Now, for example, I'll just take any example from the top so that I'll show you the application of this. 6, 13, 24, 39, 58. I'll write it down over here. 6, 13, 24. Then it was
39.
okay. These many terms are fine. Okay. I'll repeat the same process with these terms and I'll see what I'm getting. So this is just an example and we'll try to apply the same things what we have seen over here. So 13 minus 6, the first difference, 13 minus 6 is how much?
7.
7. 24 minus 13,
11.
11. 39 minus 24,
15.
15. Now point number 1. Whenever we take the first difference, we have to observe these terms and we need to check that are they following a linear sequence?
And if they aren't, do you just find the difference of that again?
Yeah. No. If they are following the linear sequence, then only this particular is a quadratic sequence, otherwise not.
Okay.
Because the first difference of a quadratic sequence will always be a linear sequence, like 7, 11, 15. They all have same common difference. 4.
Okay.
Can you see 11 minus 7 is 4, 15
Yeah.
minus 7 is 4. So it will go on like that only, and all the subsequent differences will be 4. Time to
Okay.
move ahead. 11 minus 7 is 4. I can stop over here. Okay. Now what I need to do from here is this 4 will be equated with 2a. 7 will be equated with 3a plus b. and 6 will be equated with a plus b plus c, and we are going to get 3 equations which will give me a, b, and c. Are you
Okay. Kind of.
This is a typical process which we have to follow to get a, b, c values. Okay, so this 4 is equal to 2a. 2a is equal to 4. I'm solving at the left hand side. That will give me the value of a as 2. Then I'll write 3a plus b is equal to 7. I'm just comparing. Okay, 3a plus b, first term of the first difference, is equal to first term of the first difference of the real sequence. Okay, that is 7. I can substitute the value of a from above. That is 2 over here. So 3 times 2 plus
So
b
B is 1.
B is 1. I got B. Now I have A and B, so I can very easily go ahead with the third one. Okay, so I will put A plus B plus C, which is the first term of the sequence, and that is equal to 6 as per the example. Okay,
And if A is 2 and B is 1, then C is 3.
correct. So that will give me the value of C. Eventually, I got all three, A, B, and C. I can put them, all of them in the general term. So that will be 2n squared plus n plus 3. That is the general term of the given quadratic sequence.
Okay.